Alright, so yesterday we added some command line arguments to our HTTP server, let's say tool, right? So we are able to specify the port on which this application runs and also the directory that we want to serve, right? And they also have default values. So if we just run the tool, it starts serving files from the current directory on port 8000. So if we do something like curl and we check the site itself, we are gonna see the directory listing for the current directory. Since we don't have any index.html files, maybe I'll have to also add that feature, like if you have index.html inside of a directory, it gives you that as the default, and if you don't have it, then you see the directory listing. So we can also try to do that, but yeah, for now it's showing the directory listing, and if you specify one like file, it gives you back the text content from that file. So if I do main.c, we get just the text content, and yeah, I think that's pretty decent for now. And my idea for today, as I also said last time, would be to try and refactor the response into a data structure. Wait, let me find it. Okay, so this thing, and basically try to refactor this thing into a data structure that we can fill in, like the protocol, or I guess the HTTP version, status code, headers, and then the content that we want to respond with. So yeah, that would be, I guess, what I want to try and do today. So let's try to implement that. Let's try to implement. Right now we have the request as the data structure. Let's try to do the response. So type def struct response, and also that way you'll also see basically how because I did this one off screen. So it's like, okay, you get to see how I also refactor this one in a weird way, I guess. I don't know. So I guess for now I'll keep this as char pointer, but I guess another idea would be to have it as enum, but I want to refactor it at the same time. So yeah, we'll see. Maybe yeah, I can do that. So type def enum protocol kind, and for now let's say protocol kind. We only have HTTP 1.1. I'm not sure how I can do like dot. It doesn't work. So I'll do 1.1 like this. So protocol kind, I guess protocol. All right, we have it like this. Then the next thing would be the status code. So that's gonna be an int. I guess it's more of a short int, but we can use int for it. Status code, right? Then we need a list of headers, and for that thing we can use the dynamic array from ds.h library. But yeah, why not? So define da implementation. This is for dynamic array, right? So we can have ds dynamic array headers just like that, and then the content, which should be char pointer, right? So that's how I would do this one. And yeah, sure, let's try to implement something like response serialize, right? So a function to serialize the response serialize, it should get as input the response, the structure, and then char pointer buffer, I would say, because we want to allocate it in this function. So yeah, let's have the basic result is equal to 0, then defer return result, so that we can use the return defer thingy from ds.h. Okay, and what do we need now is this kind of thing, right? Oops. Trying to build a response. So another thing would be this one is interesting. Not sure, I mean, pretty sure you can do stuff like this, but I don't think you can do stuff like this. That would be more cooler to be able to do that, but yeah, you cannot do it, or at least I'm not sure how you can do that with C enums, but whatever. Another way to do it would probably to have a const char pointer protocol kind, or I guess serialize or something, and then protocol kind, then switch over kind, and then populate switch, something like this. Wait, what? Yeah, like that. So we have all the cases here. Maybe this thing works. Okay, whatever. So clearly we need a response builder, like a string builder, to be able to build our string easily. Okay, we initialize it. Then here we can do something like %s for the protocol, %s for the status code. So then we can also do something like const char pointer status code serialize, and then something like this. And then if status code is equal to 200, then we just return 200. Okay, and otherwise not sure for now what we can do here, but like we should cover all the cases, and do for now let's just return an empty string, but yeah, like this should cover all the cases, right? So not just 200. So we have that here, then we have a new line, and then we need to dump all the headers, right? So probably let's move this stuff a bit lower down. So const char pointer headers serialize is going to be dynamic array, and I guess it should be called like headers. We'll see how we implement it. For now it's just like we imagine Yeah, I don't know. We just imagine that we have the headers in there. So yeah. Probably it's gonna be like a key value pair or something like a tuple. Okay, so let's replace this with %s. Let me just add it here just to have it as an example. And then we have the content at the end, which is like response content. Anyway, let's see. So first things first, protocol kind serialize. That's the first thing we need to put here. Protocol kind serialize, and the kind is gonna be response protocol. Then we have status code serialize, and this should be response status code. Then should be headers serialize, and here should be like response headers, and then response content. I think I'm not sure why this, anyway, why that crap looks like that, but anyway, it doesn't matter. I mean, I can just annoying. So we basically just appended everything, and then instead of doing this stuff, we could just pass here the buffer. Right, so this thing just builds that string. And that should be enough, honestly. So now instead of doing all of this stuff, we can just say we remove that, we do because we also have to build a response, right? So let's see. Response, the response probably is equal to like 0 or something, just to initialize it. And then we can do response is equal to http://11, then response dot status code is equal to 100, then response dot content should be content, the content itself. Right. Right. And I guess result is going to be equal to strlen and with the reference buffer. So we just take the length of this thing. So response serialize also returns the length of the buffer, just to make things a bit easier. So I can do something like response len is equal to response serialize. Yeah, we don't really need it to be a pointer, but why not? I mean, we could include the write call and do something like response write, and this thing is gonna get in int cfd and response the pointer response. Right, int result is equal to 0. So then buffer len and char pointer buffer, and yeah, now we can just do response serialize, and here we pass the response and address of buffer. We just have to put this one below that. So yeah, we have response write, and then I guess result is equal to write cfd buffer len, right? Something like this. And this thing returns the number return or -1. So it's like does the error check for us. Okay, so how about here we just do something like response write cfd and we just have that. But yeah, we don't really need content length. Also, I think buffer length is used here. Okay, yeah, whatever. So yeah, we just put all of this stuff. Sure, we also need to do the headers. Ds dynamic array init, and we also need to specify the item size. So that's gonna be interesting. Let's do like another structure. Like header, char pointer, key value. Basically, that's the thingy. So header t. And let's just say here, just so we know, this is header t. So like type of each element is header t. Okay, so now if we go down here, we can do size of header t. Right, so initialize that. And where did I put the example? Down here anyway. So yeah, let's see. So we need, this is the key and this is the value, and then again for that stuff. So actually content length was a bit kind of useful. So content len, just so we don't use result as, I mean, it's the result. Okay, so now let's use dynamic array append, right? So we have to append some stuff. Response headers, and then I can do header t, and then key is equal to content type, and value is equal to text/html. I think that's Wait. Oh, it wants a void pointer. Actually, I mean, not really. I can just do huh. This one sucks a bit because I have to actually create it. So header t. Yeah, this one can feel a bit annoying. Yeah, because here if I put like header t, it expects that as an element. But I need the address to it to be able to write it, because if we check, okay, I can just put null just to be able to go definition. It does mem copy, so I need the address of it. So yeah, but we can do something like this and just initialize it, and then I can wait, what? The address of header, and I don't think we even need that. Okay, so that's how I think this stuff is gonna work. Oh yeah, that's interesting. We need to stringify. I'm pretty sure there is a function I to A. Maybe it's in C++. Yeah, I guess it's C++. So then we have to do the classic. I mean, we can do string builder, content len builder, and then this string builder init, pass that stuff, string builder append, %d. Now that makes it easier. Char pointer, I guess I can reuse it. Have no idea if I can. And then this string builder build content len builder. I guess it has to be address. Content len has to be address, pretty sure. And then content len. Oh, yeah, it's pretty funny that I can override the type if I do another block. It's pretty interesting. So yeah, that's how we add that thing. So now we should have all the headers, right? And we call to response, right? which runs serialize and then, right? I mean, yeah, sure, why not? Why not? Let's keep them both. And response serialize does protocol, which is implemented with the HTTP 1.1. Then we have status code, which is not done completely yet. We have to do like 400 and other response types. Then we have the content, which is just content, and headers serialize, which is going to be interesting. That's the next one that we have to do. So I guess easiest way is again this string builder buffer, I guess buffer builder, and then we are gonna have a char star buffer. I mean, I guess you can see that it's pretty cool to have helper structures and functions already implemented, because it makes your life so much easier. And yeah, pretty nice. So let's try to do, I guess we are gonna return a buffer at some point, and then string builder build buffer builder, and then address to buffer. That's gonna happen at some point. And also string builder init buffer builder, and now we are gonna have a for loop. So for less than is headers dot count, and here we need header the header, and we can do stuff like this dynamic array. I mean, it exists, but yeah, weird. So here we need the that's why I'd like to have it as a pointer, maybe. Oh, am I? Yeah, my Rust brain started to show. So we have headers, then we have the index and the address to where we write that thingy. So in header, and then we do ds, I guess ds string builder append. We do the buffer builder, and then the string is going to be something like this: header dot key, header dot value, and don't forget the new line. So yeah, I guess that's all for the headers serialize. And yeah, I guess here we need to do address. So yeah, let's see if it's gonna work first try. That's gonna be interesting to see. So it's, you know, listening, and if we curl that thing, holy shit, what? Did I forget to compile it? It has an extra new line though. And I think I know why. It's because here we add an extra new line. So we should, well, it was basically almost first try if you ignore that thing. So yeah, and it still works. I mean, let's ignore the directory listing. I'm still yeah, trying to figure out how to implement it. So yeah, but you know, hopefully this was a bit useful. I mean, I know it's not using, you know, the raw stuff, I use like my wrappers around, the, I guess, how is it called? str sprintf and stuff, right? It uses wrappers around that because I implemented this stuff a while back, so I don't have to use it, right? So I don't have to sprintf and do all of this crazy stuff. So yeah, it makes it much easier. So hopefully it gives you motivation to implement your own wrappers around functions like that. And yeah, I mean, hopefully it makes sense how, or I guess why do people use data structures for things like responses or requests, right? You don't have to do everything manually. You can just have a structure. It's a bit more abstract, so you don't have to think about how it looks like in memory. You just say, okay, put the protocol, put the status code, put the content, maybe put the headers, and I don't really care how it looks like as a string, and I care more about I guess what value the status code has, for example. So yeah, I think this is a pretty cool idea, because now we understood how the response string should look like, or I guess also how the request string looks like. And after that, now we don't care about them anymore. We just care about covering all the edge cases now. So we can make that easier by introducing a data structure that we can serialize easily, and now we can never look at this piece of code again, because it's done. It's always gonna work probably. Maybe just this thing has to be filled in, and yeah, the rest I guess is fine. So yeah, I would say decent progress for this one too. So yeah, even this respond with 400 should be easy to do, I'd say. So yeah, let's try to do that one. So response, right? So should we put response afterwards, like in defer? So this is like everything went well, we respond with 200. Here I guess we can say like 404 maybe, and here we can do 400. So yeah, I guess so. So we could even take this thing, put it in the beginning. Yes, if this thing fails, we can do something like response status code is equal to 500, because wait, we couldn't read the request. So pretty much it's an internal server error, I guess, because it's not really about parsing, but it's about reading. I don't know when this can happen, but it could happen. Then response status code, here I'd say 400, because we failed to parse the request, and that's usually a bad request, I guess. So we just fill it in with 400. Then yeah, we return defer. Then here it's most of the time should be a 404, because the path doesn't exist. But it could also happen that we fail to read from the file because we ran out of memory or something. So then we should handle that differently, but that's on me. So we could do like to do different return code for different types of errors, like -1 for not found, -2 for out of memory, and things like that. so we could easily check each thing. So yeah, 404. Otherwise we get the content length, and yeah, we just say, okay, if everything went well, we do a 200, we put the content here, we put all the headers, and then we write this thing here in defer. So that way, here we write something, also here we write something, and so on. Yeah, I'm not sure how 500 string should look like, but we can come here and say something like if status code is equal to 400, like, is it bad request or something? I don't know. Then it's 404, like this. I mean, not found, I'm pretty sure it's not underscore found, but for the other ones, no idea. Like 500, I don't know. But yeah, let's try to compile this thing, and let's just say we try to access something that doesn't exist. So it throws an error, no such file or directory, and then read path, so 272. So yeah, I'd expect it to do a 404. Then I guess we also need to add some content and some headers. All right, so probably the headers, well, let's move this init to the top. So we could easily just take this stuff, I guess all of that, put it here in the 400. So it's like text HTML, then we have some whatever. Let's have maybe find not found str is gonna be not found. Not sure, but let's try it. So response content is gonna be not found string. What the fuck? Oh, not found. And here strlen of not found str. So we could just do that, because maybe we also need to have those things. So it responds with not found, and if we curl headers only -i, well, for this one, I mean, I'm pretty sure you could just see the headers. Yeah, -i, strange. So if we take a look at headers, it returns bad requests, right? So, well, wait, what? That's interesting. That's because -i probably does another kind of request, right? It does a header request, not a get request. Yeah, that's cool then. But see, we get a not found, so it's a 404. So then it means that we can test for 400 by taking this stuff, going in the 400 category, having the same thing. Then instead of not found string, let's try bad request string, and then have bad request. So bad request string, and here it's bad request. Yeah, I mean, it still feels like we do a lot of copy pasting, but I mean, we could do post and it returns bad request. So I mean, even bad request works. That's pretty neat. But yeah, for 500, I mean, I'm not sure what the header looks like, but I mean, I still think it's pretty cool to be able to have a response structure. Maybe we can come up with an easier way of building headers. Maybe having this hidden behind the function, but we still have all of this stuff, so which is annoying in C, converting from int to string. So yeah, we have to think about this one too. Maybe we can have it hidden behind a function that takes the value as an int. So yeah, more refactoring is coming, but I think for now it's a decent tool. So yeah, hopefully you learned something interesting from this one. Maybe more on the lines of why we use structures, and yeah, how to handle it. Like, sure, reading a structure might be a bit more interesting, like parsing it, but I'd say also serializing the structure was decent. So yeah, let's see each other in the next one.